All right, 2-4. Let's go ahead and get started talking about complex numbers. So a complex number is something that involves the imaginary unit I. All right, so a lot of you have seen this before. I is defined as the square root of -1. So we've moved beyond all the real numbers and we're getting into some imaginary numbers. And so when we add complex numbers together, what we're going to do is we're going to add all of the regular numbers together, all the imaginary numbers together. All right? Problem like this down here, square root of -9, we can pull out 9 apart from -1, and so the square root of 9 is just 3. That can come outside, and then the square root of -1 just becomes I. All right? So we'll treat square roots just like normal, but the negative we can get rid of by throwing an I on there. All right? And so standard form looks like this: the regular numbers plus the imaginary numbers, a plus b I. All right? So definition of a complex number, again, standard form. If b equals 0, then we don't have any imaginary parts and it's just real. All right? If we have a plus bi were imaginary, if you don't have any regular numbers here, then we're going to call it a pure imaginary number. Right? If it's just bi, it's pure imaginary. Okay, so equality of complex numbers, a plus bi equals c plus di. That's only true if the a's match exactly and the b's match exactly. I think that kind of makes sense. All the imaginaries have to match and all the regulars have to match. All right, so that makes sense for addition and subtraction. We've talked about this already. Add the regulars, add the imaginaries. So let's run through these. 4 plus 1 is 5. 7 plus -6 is 1i. Boom, there's your answer. 1 minus 4, -3. 2 minus 2 is 0, so that goes away. -3, there's your answer. 3i minus 3i, those are going to cancel. Minus 5i. How about our regular numbers? This is positive 2, the negative would distribute. And minus 2, so that goes away. We've got -5i, pure imaginary on that one. Here we've got 3 plus 4 minus 7, so that's going to be 0. Here in the imaginaries we've got 2i minus I, and so that goes away also. 0 is what you're left with. All right, so see if you can do that for 21. Just do one of them here. All right, so same rules apply when we're going to multiply. So distributing in, 4 times -2 is -8. 4 times 3i is plus 12i. And there you go. That's your answer. Quick one there. All right, how about when we have to FOIL? Same rules apply. First, outside, inside, last. And so here comes the kind of new part, minus 3i squared. Remember what I squared is? Let's put these together first, plus 2i. I squared is -1. Because I is the square root of -1, I squared just becomes -1. All right, so now we can clean this up and make it 8 plus 3, which is 11. -3 times -1 becomes positive 3. All right, so same thinking here. This is a 9 minus 4i squared, because it's plus and minus. The middle terms are going to cancel. So this is 9 plus 4, which is 13. I squared turns into -1. All right, last one here. This is 3 plus 2i times 3 plus 2i. Don't fall into the trap of just doing 3 squared and 2i squared. Gotta FOIL it. 9 plus, you're going to get 12i plus 4i squared. So that's going to turn into -4. So we're going to get 5 plus 12i. All right, your turn. Problem 31. Okay, let's talk about conjugates. So in a lot of cases, we're going to want to get rid of the i's, right? So if you think back to this problem here on C, when we have 3 plus 2i, if you have the exact same terms but a minus, look what happens. We don't end up with any imaginaries at all. They're going to cancel out. And what this is called is the complex conjugates. All right, if we have a plus bi, the conjugate is a minus bi. All right, and so the i's will always go away if that's your case. So multiply each complex number by its complex conjugate is our job on example 3. 1 plus I. We're going to need to multiply by 1 minus I and see what we get. 1 minus I squared, which is 1 plus 1, so 2. Let's try the next one. 4 minus 3i. What would the conjugate be? Conjugate would be 4 plus 3i. So we're going to have 16 minus 9i squared, which is the same as 16 plus 9, so we get 25. Okay? All right, so see if you can do the conjugate and multiply for 41. Okay, so writing a quotient of complex numbers in standard form, we are not allowed to have square roots in the denominator. You know this from algebra. From algebra 2, we're going to have to get rid of that I because I involves a square root. So how do we get rid of it? Well, we multiply top and bottom by the conjugate because that's going to get rid of our i's, and so that's going to get rid of the square roots. So let's FOIL the top. 8 outside, 4i inside, 12i last plus 6i squared all over. This is going to be 16 minus 4i squared. We'll clean it up. And so we're going to have 8 minus 6, because remember this is going to turn into negative 6. So we'll have 2 plus 16i on top. And on the bottom we're going to have all over, this is going to turn into plus 4, all over 20. Everything's even, so we can reduce that. 1 plus 8i all over 10. No more square roots in the denominator, no more i's in the denominator, and that is our answer for example 4. All right, so you are up and try 53. Okay, so complex solutions of quadratic equations. When you do the quadratic, before, if we did the square root of negative 3, we would stop. We would say, nope, we're done, right? But now we're going to pull the negative 1 out, make it an I, and just leave the square root number by itself. All right? The number root 3i is called the principal square root of negative 3. All right? If a is a positive number, the principal square root of the negative number is defined like this. Pull the negative out and give it an I. So, writing complex numbers in standard form, here's the first one. Root 3, oh, I didn't delete that. I'm supposed to cover that up, but that's our first step. Root 3i and times root 12i. And so we could finish this. We can multiply the square root numbers. 12 times 3 is 36. We can multiply the i's and get I squared. So we're going to get 6, and we're going to get negative 1. And so we're going to get negative 6 as our answer. Let's take a look at the second one here. We've got root 48, and get rid of the negative by pulling the I out, minus root 27, pull the I out. And let's see if we can reduce this at all. 48 could be 16 and 3 times 3, so that's going to be 4 root 3 I minus, let's see about 27. That can be 9 times 3, so it's going to be 3 root 3 I. And so the final answer, 4 minus 3 is going to be 1 root 3 I. That was B. Alright, and so we'll finish up with C. Let's FOIL this thing. We're going to have negative 1 plus root 3i times negative 1 plus root 3i. And so our first, we're going to get 1. We're going to get minus root 3i. We're going to get, let's see, again, minus root 3i. And then we're going to end up with plus 3 I squared. Remember, square root times square root would go away. So that's really minus 3. So we'll get negative 2 minus 2 root 3 I. That's our final answer there on C. All right, so go ahead and try 63. All right, example 6, and I believe this is our last example. Yes, it is. So let's go ahead and find the compact solutions of a quadratic equation. So now we're solving. So x squared plus 4 equals 0. We want x by itself. First step, let's minus that 4. X squared equals negative 4. Before we would have stopped because we got a square root. But now we can say x equals root 4i. And now we're going to say x equals 2i. And when you do the square root here, don't forget to do plus or minus. So x equals plus or minus 2i. All right, b is a little more complicated because it doesn't come out cleanly, so we're going to go into the old quadratic equation. Negative b, so negative negative 2, plus or minus the square root of b squared, minus 4ac all over 2a. And so let's clean this up. 2 plus or minus the square root of 4 minus, what do we got there? 12 times 5, 4 minus 60, which is negative 56, all over 6. All right, and so let's pull that I out. So now we can do it. 2 plus or minus root 56 I all over 6. And does anything go into 56 cleanly? It's 4 and 14. So 2 plus or minus 4 comes out as 2. 14 is left in there, all over 6. And at this point we can reduce the 2's and get a 3 there. So we're going to say 1 plus or minus root 14 I all over 3. All right, and so that is our final answer. One more problem and you're all done with your notes. Try 69.